All right, so we've learned a few ways to factor. We've learned the box and tiling. So those are the two ways we've learned. Now, sometimes we were playing a game today in class, and my kids were like, it's not fair. It's not fair that you're winning, that you're beating us. Well, yeah, it's not fair because some of these factors I know how to solve by eyeballing it. So the strategy I'm about to teach you about 3 different special factors. First one, we're going to learn about eyeballing it. We're going to learn about the difference of two squares, and we're going to learn about perfect square trinomials. And all 3 of these are ways that we can kind of shortcut solving these factoring. So we don't have to do the whole box. We don't have to bust out our tiles. We can use other things to help us do it. Okay. So the first strategy is eyeballing it. Okay. So what this means is we're going to look at it and figure out what the answer is. We're not going to put it in a box. We're not going to put down tiles. Okay. Eyeballing it works when A is 1. Now, as you get stronger at factoring, you may be able to eyeball it like with factors, with bigger ones. But really, honestly, I only eyeball it when A is 1. So the first thing you're going to do, so you remember how we have, like when we did our factoring with the box, we had the box and the X. All we need, and after a while you won't even need the X, but the X is kind of where you can start with for eyeballing it. So we're still going to have that same conversation. 1 times 8 goes up here. B, which is 6, goes down here. So A times C goes on the top and B goes on the bottom. And since A is 1, really we're just putting 8 up there and 6 on the bottom. So we're looking for things that multiply to give us 8, but add up to 6. I want to know what adds up to B but multiplies to C. Well, I could do 1 times 8, that's not 6. I could go 2 times 4. Oh, 2 times 4 is 8. 2 plus 4 is 6. Those are both positive, so I'm going to say it's x plus 2. X plus 4, and that's my answer. And I'm going to rewrite this just so you can see. That is the factored form of that trinomial. Okay, let's try another one. Let me zoom in a little bit. We'll try this one. Okay, so I need factors of 10 that add up to 7. Okay, factors of 10 that add up to 7. Well, I have 1 times 10, that's 11. 2 times 5, whoa, 2 plus 5 is 7, 2 times 5 is 10. They're both positive, so I have x plus 2, x plus 5. All right? And again, just because it looks weird with the boxes, x plus 2, x plus 5. All right? This guy down here, you can take a second if you want to pause right now. You can take a second and try these 2 on the bottom. So I'll let you pause. Okay. So let me show you what I got for these 2. Okay, so I need factors of 12 that add up to negative 7. Okay, so this is going to be a little different. So I could do 1 times 12, which is 12. 2 times 6 gets me, well, 1 times 12 is 12, but it adds up to 13. 2 times 6 is 12, gives me 8. 3 times 4 is 12, and 3 plus 4 gives me positive 7, but I don't want positive 7. Well, negative 3 times negative 4 also gives me 12, and it adds up to negative 7. So another thing you always remember, don't forget about your negative factors. Every number has, so if it has 2 positive factors, it's also got 2 negative factors that are the same numbers, okay? Well, so that would be x minus 3 and x minus 4. Okay, and I'm rewriting it because that, just so you can see what the factors look like and it doesn't look weird in the box. And this last one is actually the trickiest one of all, but still it's not really that hard. We need factors of negative 15 that add up to negative 2. So I could do 1 times negative 15, that gives me negative 14. 2 times nothing. 3 times negative 5. So 3 times negative 5 is negative 15. 3 plus negative 5 is negative 2. So I would have x plus 3, x minus 5. So the next time we're playing, the infinity mode, you might be able to answer some of these quickly as well. So remember, all that you need is the x part. And really, as you start to get more stronger at this, you won't even need that to do eyeballing it with factoring. Okay? So that's the first special factoring form, which is eyeballing it. Okay? The next one is called the difference of two squares. Okay? So emphasis on difference. Okay? Difference is the math word for subtraction. Okay, so I'm going to find the difference between these 2 perfect squares, a squared and b squared. When I have the difference of 2 squares, each set of parentheses is going to have different signs. Okay, so difference, different. So if I look at this one, it says I'm going to take the square root of the first term. So what I'm going to do is actually I'm going to start by drawing a set of parentheses. Okay? I take the square root of the first term, and it goes in the front of my parentheses. Okay? I'm going to take the square root of the last term, and it goes in the back of the parentheses. I put a plus in one and a minus in the other. And that's it. It's factored. I don't have to do anything else. Okay? So remember, the sign is always going to be different for difference of two squares. All right? And like, that's it. Okay? Now, this one I could actually do two ways. First of all, we say that when we factor, our first step is always to take out the greatest common factor. Okay? So technically, I should divide this by 4, and I would get 4x squared minus 25. Okay? That's one way. And then I would do the same thing. Here I would say 4, and then I would make two parentheses. The square root of x squared is x. Square root of 25 is 5. I would do x plus 5, x minus 5. I could also just factor it exactly like I see it, because 4 is a perfect square, x squared is a perfect square, 100 is a perfect square. So I could also, in addition to doing it that way, I think this is more completely factored. Okay? But you could factor it just by saying the square root of 4 is 2, square root of x squared is x, square root of 100 is 10, plus and minus. Okay? These are actually, all three of these are equivalent. Okay? Now, this one here, a lot of you are going to be like, I hate everything about this because it's not in standard form, and we want to see our x's first. But you can factor this one like it sits as well. And of course, with this one, you could also take out the 4, which would theoretically be more precise. You'd have 4 times 4 minus x squared. Okay? But I could also just factor it like this. The square root of 16 is 4. That goes in the front. Square root of 4 is 2. That goes in the back. The square root of x squared is x. That goes with it. Put a plus in one and a minus in the other one. On this one, you'd have 4, and then my two parentheses would be 2 in the front, x in the back, a plus on one and a minus on the other. Okay? Now this last one, it's really kind of funny. This one kind of like freaks a lot of y'all out too, because what's with the y? Same thing, guys. I make two sets of parentheses. Take the square root of the first term. The square root of x squared is x. Square root of the second term. Square root of y squared is y. One gets a plus, one gets a minus. Okay, so that's dots. So we've talked about eyeballing it, which is just using, what adds up to C to give me, adds up to B, but multiplies to give me C. Then we've used difference of two squares. If I have a perfect square minus a perfect square, I take the square of the first one, the square of the second one. One gets a plus, one gets a minus. Okay, let's talk about perfect square trinomials. Take 3, by the way. This is the third time I've tried to record this. The last one I ended up speaking total nonsense, and then the first time I said some words I wasn't supposed to say. So let's see if I can make it happen this time. Third time's a charm. So when we look at this, a perfect square trinomial means that this trinomial is as a result of squaring a binomial. So I took something like, maybe I took x plus 2 and I squared it, and this is the binomial I came up with, which is going to be x squared plus 4x plus 4. So this is a perfect square trinomial because it's the result of squaring a binomial. Okay? So there's some rules. Okay, so the first rule of perfect square trinomial club is we don't talk about it. But the second rule of perfect square trinomial club is the first and the last terms must be positive squares. So this is like my first important thing. So if I look at all these, x squared and 9 perfect squares, x squared and 100 perfect squares, 4x squared, 4 is a perfect square, x squared is a perfect square, 1 is a perfect square, 100, x squared, and 9, all perfect squares. So these all meet the first criteria. Okay, now, B, we figure out, so the sign that we use in between them, this x plus 2 or x minus 2, is determined by the coefficient of B. So you see how when B is like this, when our linear term is positive, our binomial is positive. When our linear term is negative, our binomial has a minus in the middle of it. Okay? Third thing. Okay, so let's just find a place to write this down. Okay, so this is first thing. Sign of the linear term determines the sign in the binomial. Okay? So that's our second rule, rule 2. Okay, now, the last rule is super weird. Once I start doing this, it'll start to make sense. But here's just go with me on this, okay? Just go with me. I would never lie to you about math. Here is the last rule. Okay. B over 2 squared equals A times C. What? Okay, I'm going to show you what that means, okay? And this is the last thing, and it has to be true in order for it to be a perfect square trinomial. Okay, so here's what you're going to do. Okay, so I'm going to start by making one set of parentheses, and I'm going to put a square next to it. Okay, so I'm going to look at these two. So this is a perfect square, and that's a perfect square. All right, I'm going to have a plus in the middle because that's a plus. Okay. The first number goes in the front, the square root of the first term goes in the front, the square root of the last term goes in the back. Now, this is the answer, but only if b over 2 squared equals a times c. Well, remember, a is 1. So 6 over 2 squared should equal 1 times 9. So let's see if that's true, okay? And when I say a, b, and c, I'm talking about ax squared plus bx plus c, the letters in standard form. Okay, so if I take 6 divided by 2 and I square it, I get 9. If I take 1 times 9, I get 9. Those are equal, so this is a perfect square trinomial. All right, I'm going to change my pen because I'm having a reflection of the light. Now let's take look at this binomial right here. I have a perfect square here. I have a perfect square there. So let's look at this. I have b over 2 squared equals ac. So this is b, this is c, that's a, and that's c. Okay? So negative 10 over 2 squared should equal 1 times 100. Well, negative 10 over 2 is negative 5 squared. Well, negative 5 times negative 5 is 25. And that's not 100. This is not a perfect square trinomial. So I cannot use the perfect square trinomial shortcut to factor this because it's not a perfect square trinomial. Okay? It doesn't work if a over c. Now, if I change this to 20, it would work, but that's not the expression they gave me. So this is like really important. I cannot just like, oh, perfect square, let's go. It has to, so b over 2 squared has to equal a times c, and if it doesn't, this doesn't work. So I think I've got a PST here. I've got a perfect square, all right? A and c are both positive, so I'm going to try b over 2 squared equals a times c. So that would be 4 over 2 squared should equal 4 times 1. Well, 4 over 2 is 2. 2 squared is 4. 4 times 1 is 4. This is a perfect square trinomial. So I can use this to factor it. The square root of 4 is 2. The square root of x squared is x. The square root of 1 is 1. This is a plus, so I put a plus there. Okay, let's try this last one. And how about you guys try this one? I'll give you like a little time. You can pause and see if we get the same answer. Okay, so again, I have a perfect square. I'm feeling pretty good about it. A and c are positive. So my quadratic and constant terms are positive. So now I got to see if my linear term is right. So again, I'm going to do b over 2 squared. And if I'm right, it should equal 9 times 100. Okay, so negative 60 divided by 2 is 30. If I square that, I get 900. 9 times 100 is 900. This is a PST, so I can use my pattern. Square root of 100 is 10. Square root of x squared is x. Square root of 9 is 3. This is a minus, so I put a minus there. And that's all perfect square trinomials are. Now again, this is the most important part though, right here. If this isn't true, then everything else being a perfect square, it doesn't matter. Okay? And for example, if this right here, instead of being plus 9, if that was minus 9, or if this one was minus 9, it wouldn't work because A and C have to be positive. All right? Now remember, you can always stick any of these in the box and just factor. Okay? Nothing says you have to use these rules, but I will tell you, if you memorize these rules, it'll make some of the factoring that you're going to do a whole lot faster.